Let's continue with two pointers with this amazing platform Chai Visual at dsa.chaicode.com. This is the link. You can use this link to avail a 7-day free trial here. Use this link. So start with DSA, then move to third question, that is threesome. Okay, so this is the question. Find all unique triplets that sum to 0. Given an integer array, find all unique triplets that sum to 0 with no duplicate triplets in the result. So the problem threesome, and also we did another problem here, that is twosome. What is the okay? So we did twosome here. In twosome, what we are given? We are actually given in twosome a target, and we have to find two elements add up to target. This is our twosome. We are given a target and an array. The array is sorted, and we have to find two elements add up to the target. In threesome, what they are stated is that find three elements with sum equal to 0. So in twosome we have to find two elements. Here we have to find three elements. They are actually, we are given a target there. Here the sum is 0, or the target we can say is 0. This is the thing. So in twosome we have to find two elements. Here we have to find three elements. In twosome specifically we return the indexes. You can return the value also. Here it's basically asks the value of the pair or a triplet that adds up to 0. So if you just go here, okay, I think I need a refresh. Yes. So see the question. Given an array of integer nums, return all the triplets such that I not equal to j not equal to k. Okay, so three different indexes, not same indexes, and nums of I plus nums of j nums of k equal to 0. Notice that the solution set must not contain duplicate triplets. We have to reduce the duplicate triplet. That is the tags you can see there. Let's come with array. Let's take this one. Okay, so here we have to find three elements that add up to 0. So what we can find, if we take these three elements, minus 1 0 1, we add up to 0. Yeah, is a triplet. Or if we take this minus 1, this, okay, this minus 1, then this minus 1, and this 2, these three elements. So what we find, minus 1 0 minus 1, and another one is minus 1 minus 1 2. Okay, this is two pair, I think. Yes, minus 1 minus 1 2, minus 1 0 minus 1, minus 1 0 1. Only these two can add up to 0. So how could we find this? Let's take the array again here. Okay, so what would be a brute force approach? If we use 3 for loop. Like one for loop is loop I, we just point here. Then another for loop is j, that point here. Another for loop is k, that point here. Okay, so we put 3 for loops and with 3 I at 0, j is I plus 1 and k is j plus 1. Okay, so just we traverse through the array by loop by loop. Does it add up to 0? Yes. Increase the k. -1, 0, 2. That is that up to equal to 0? No. Increase it. Is this equal to 0? Yes. No, it's not equal to 0. Sorry, no. Then go there. Is this equal to 0? No. Now the j to here. So is this equal to 0? So and k to here. Is this equal to 0? No. Is this equal to 0? -1, 1, -1. No. Is this equal to 0? No. Increase j. Put k here. -1, 2, -1. Yes, it is a 0. Add it to the answer. Increase k. Is it 0? No. Put j here. Add k here. Is this 0? No. Increase the I. Put the j here. Put the k here. And do the loop again. Like, is it 0? No. Is it 0? Yes. 0, 1, -1. But we already get 0, 1, -1 here. And we have to take unique ones. So no duplicate values. So these things already happens here. So let's visualize it with this. You can see a cool pseudocode here already given. So first, okay, let me do this. We go there, we put the I pointer at the 0th index, put the j pointer at the I plus 1 index, put the k pointer at the j plus 1 index. Then increase, then take the sum is -6, not equal to 0. Then we increase the k, sum is -5 here. Okay, increase the k, sum is -4, increase it, -3, no. Again increase the j, equal to put the k here, is it equal to 0? No. Increase the jk, no. 0, no. Increase the j, put the k, is it? No, no. So we don't get it. Now put the k here, does it 0? No. Now increase the I. Now again put the j equal to I plus 1, k equal to j plus 1. The sum is -2, not equal to 0. Increase it. Okay, increase it. Now it is 0. Clearly say -1, -1, 2. We get an answer. Put it into the answer. Put it into the answer. Let's increase the j. Put the k and we get another answer. -1, 0, 1. Another answer. It is not duplicate, it is a unique one, so add it to here. Increase the k, increase the j, get the k, increase the I, j, k. We got another answer. -1, 0, -1. Okay, this is same, but increase it, increase it, increase it, put it here, j here, k here. Now just go to this last step, dedupe the result. We see a duplicate here. Let's just remove this. Just remove this pair. It will automatically remove it. So let's write the pseudocode here. What we are given, a function which takes an array or ARR, a for loop for I 0 to n minus 3, y n minus 3. Okay, let's take it for j start from I plus 1 to n minus 2. Loop for k, it start from j plus 1 to n minus 1. Calculate the sum here, like if ARR of I plus ARR of j plus ARR of k equal to 0, then just into answer the end when you leave the whole for loop, 3 for loop. Just so this line is for removing all the duplicates here. Let's evaluate it and let's see. Yes, we nailed it again. But now the question should be, I make I to n minus 3, j to n minus 2, k to n minus 1. Okay, let's take this array. These three variable I need. Okay. Let's take this variable. I need these pointers. Surely. So here you could see that I is n minus 3. Okay, so remove this. I is our first pointer. I. We started it from 0. Okay. We need 3 elements to add 0. And we had 2 pointers also here. I, j and k. J, k. I, j is always I plus 1 started from. K is always start from j plus 1. So how far can k goes? This much. How far j goes? This much. How far I goes? This much. Why? Because we need 3 elements. If we put I here, we can put j is I plus 1. J is I plus 1 here. How could we put k? It will be added out of bound because this is the last point. There is no element after that. So I have to, last index of I have to be here, j have to be here, k have to be here. That's why I is stop at n minus 3, j at n minus 2 and k at n minus 1. Okay, let's copy it again and solve this here. Solve it on the go. Let's see what happens. Int n equal to nums dot size. Okay, then we have to take unique elements. So how could we take unique elements? Okay, that is a question because we have to answer it in vector of int. What if we use a set? We just, let's suppose we put 3 elements here, we got 0. We take this and we just put this in a order, like it is sorted, although -1 0 1, So we sort this because array is not every time sorted. They're not specified it that will be a sorted array. We just sort this and put it the whole thing into a set. And set is consisting of unique elements. Okay, let's see. We will take a set which will be taking a vector int type st. Okay, so for int I equal to 0, I less than n minus 2, I plus plus. Why 2 here? Because the last index will always be n minus 3, not n minus 2. It is not equal to, it is strictly less than. For next, the j loop, j less than n minus 1, j plus plus. Then for the k loop, j is from I plus 1, k is from j plus 1, j less, so k less than n, k plus plus. Okay, if nums of I plus nums of k plus nums of should be j, nums of j and nums of k equal to 0. Create a temporary vector and add these three numbers. So I just copy pasting it. If it's 0, just put this 3 number into a vector, then sort the vector and put this vector into this set. So it will be st dot I insert temp. Put this vector into the set, but we have to answer a vector of vector int format. So this, oh, make an answer which will be st dot begin comma st dot end. So what this will do, this will take the set, copy every element from the set and inserted it into this answer. At the end, just return answer. Yes, let's submit it. I think it should give a TLE because it's O of n cube solution. Yes, it gives us a TLE. Why TLE? Because we are using these three loops and it will go till n minus 3, n minus 2, n minus 1. In the worst case, the time complexity would be n minus 3 into n minus 2 into n minus 1. If you just take this like, and if you multiply it, the highest value after the multiplication would be n cube. There will be more values here, but the highest value would be n cube. So the time complexity of this solution is big O of n cube, and we don't take any space, so it big O of 1. Okay, so now move to the optimized solution, where we will be using a simple thing. We will sort it because it is not mentioned that it will be sorted, plus two pointers approach. This will be the optimized approach. Just sort it and use two pointers approach. Let's do it. Let's, yes, let goes to optimize, which is sort plus two pointers approach. So first sort this array like it is sorted -4 -1 -1 0 1 and 2. Okay, so now we could do how we use a two pointer. Let's see it here first. Yeah, this array is in sorted order. You can clearly see this array is not in sorted order. So let's sort it. This would be -4 -1 -1 0 1. It's sorted -1 -1 0 2 1 -4. Okay, now remove this array. This is a sorted array. Okay, take three pointers as usual. I, J, K. Take three pointers. First pointer should point here. We need three elements. Okay, let's keep it simple. We need three elements. But think of it like a two pointers. What we did in two pointers, we just remove the I for here. Let's suppose we have two pointers J and K. Okay, I shouldn't be there here. J and K. What we did in two pointers, we put one pointer at the left side, one at the right side. Okay, and add them and see if it is equal to target or not. But here we have to get three elements. Okay, how could we get? Put I to the first, now j to the I plus 1 and k to the last index. How achieve this? Let's suppose we are looping through the array. Okay, but first got to understand what we do. So I at -4, j at -1, k at 2. Add them. Does the equal to 0? No. So our what we did in two pointers, we check if it is greater than 0, greater than target, we reduce k. If it is less than target, we increase the j or the left pointer. Okay, so for here our target is 0, so add the -4 -1 2, it would be -3 -3, so -3 is less than 0. Okay, so what we did when there is a when the value is less than target, consider 0 as the target. So it is less than target. What we did, we increase the left pointer. Here j is the left pointer, k is the right pointer. Increase it. It is the same. Increase it. It is minus. It is, yes, it is -2 now. Still less than j. Increase it. It is still -1. Increase it, but the condition not satisfied. We reach to the end. Increase the I now. Put the j here. Take the k. Add the -1 -1 2. We get our first array in sorted order. Let's check here. Here we specifically sort the array so that we can remove the duplicates. But here we just take it like, oh, we get this and just put it into the array. Okay, so if we get this, what we did, increase the j here, decrease the k here. Okay, we get another one, -1 1 0. We get another one. So first one is -1 -1 2, and the second one is -1 1 minus 1, 0 and 1. This is actually in sorted order. Okay, it's done. In the next step, this will increase, the k is get less than j, so the condition breaks. Increase the I, but let's see here. Let's put the k here, j at here. Okay, I at here. Okay, now think of it. If I increase the I, the j would be here, k would be here. We take, it will be greater than 0. Let's say 2 minus 1, 0, 1. It will be greater than 0. For greater than, we reduce the right pointer, which is k here, and we get minus 1, 0, 1. But we already get it here. How could we achieve it? Okay, like we get a duplicate. Maybe you think like we can use a set, but we don't use a set here. We directly use the vector here. Let's see it. So I is here, j at here, k at here. In this condition, we get our second solution. Okay, so then it increases the I. Let's see, the previous I. The previous I is minus 1, the current I is also minus 1. So what we did here, we increase the I1 again, or say continue. If array of I, current I is equal to array of I minus 1. For this condition, we have to continue one step a. We have to increase the array 1, the index I ones, because so that we can reduce to get duplicate arrays, duplicate answers. For that reason, let's see it here. Okay, so here you can also record, advance and skip dupes. For this we have to do it. Also another reason it here, when we increase the j or reduce the k, if we get similar type of element, we have to reduce, we have to continue it again. Okay, let's see it here in code also. We will take another I pointer till n minus 3. We already explained why n minus 3. Get our I pointer, we get our left and right, which we take there as j and k. We get this. Okay, we don't get this solution. For this we can use I greater than 0. I'll explain it. Then check the while condition. If left is true, left is less than right, add the sum, it is minus 3. So sum is less than 0, so increase the left. Now again sum it, minus 4, minus 1, 2, the sum is still minus 3. Till the sum is less than 0, increase the left. The sum is still less than 0, increase the left. Okay, the sum is still less than 0, increase the left. So also for this case, we reach the at the end of the array, because after that the left will be equal to right. So now increase the array. For the I, we will use a for loop. Okay, a simple for loop till n minus 3. Increase the I, get the left and right. See, the sum is actually minus 1, minus 1, 2. It actually is 0. Yes, we get our solution. Add it to found. Let's see, we found the solution here. We increase the left, we decrease the right in at the same time. We did it. We found another solution, minus 1, 0, 1. All are in sorted order. We found another solution. Let's move it here. Let's move and let's see. Let's see here. We get the solution of minus 1. Then we just increase the I again, and what we get? We get the previous I is also minus 1. The current I is also minus 1. So we skip this I. Let's see. We skip this I. See the visualization. We just skip this I and go to the next element, so that we doesn't get any duplicate element. Okay, so previously we have to, like in code, we have to use a set, then sort it, take a vector, then sort it, then again insert a vector. Here we don't have to do all of these things. Put left and right here, not equal to 0, so don't need it. And we get our solutions: -1, -1, 2, -1, 0, 1. Okay, so this is now. So write the pseudocode, which is function will take an array of ARR, then sort ARR, okay, sort ARR, then take a for loop. I start from 0 to in -3, in -3, take 2 pointer like left. Let's go with the solution, that is I plus 1, and another one is right, is in -1 at the last index. Then while left is less than right, we have to use the loop. Calculate sum, which is sum equal to array of I plus array of j plus array of k. Okay, so we missed a condition here, that is if I is greater than 0, that's mean I is not at the this first index. Okay, and array of I, the current index of array, equal to array of I minus 1, the previous index, then simply continue. If the I is not the first index and array of I equal to array of I minus 1, we see the thing here like -1 -1. At that moment we just continue it, go to the next element, get the sum. If sum equal to 0, let's take it, store the store, let's do it, store ARR of I, comma ARR of j, ARR of k, store in answer, store this in answer, then simply left plus plus and right minus minus, increase it. But here we have to check another condition. If we get similar element, while suppose I at here, j at here, k at here, k, let's suppose this is again -1. Okay, let's suppose k at here, or let's think of this, for this the value will be same as for this, so we just skip it because we have to take the unique values. For the sake of unique values we have to leave some places. So while left is, the left should be greater than sorry, less than right, and and array of left equal to array of left plus 1. We get same element here, so left plus plus, sorry, left minus 1, previous element, because left is the first index. Same goes for here also. Okay, no tab, and array of right equal to array of right plus 1, then simply go and do right minus minus. So surely here else if sum is greater than 0, if sum is greater than 0 at target, what we did when the sum is greater than target, let's see it here clearly. When the sum is greater than target, so greater than, we have to make smaller element, so right minus minus, else only one condition remain, that is left plus plus. Okay, let's evaluate it and let's see we did it right or wrong. Okay, it take, okay, variable name j or k are used in the set of left and right will lead to error since, okay 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 okay, it should be array of right equal to left, but it should actually be array of, okay, we miss this logic. Yes yes yes, why I use j? Actually, sorry, right, it it should be left plus 1. AI suggestion. Okay, I make another mistake. I can clearly see it here. Sorry, sorry, sorry. Okay, 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 okay. Yeah, I understand where I make the mistake. Actually, here it should be left and it should be right. Let's evaluate it. Maybe they should run this time. Yes, we nailed it. Okay, I have to copy this. Let's remove it here. Put the pseudocode here. This is the pseudocode. First, sort the nums dot size. Nums dot begin and dot end. Okay, let's take the in here, which is nums dot size, or int I equal to 0, I less than n, I plus plus. So this should not be n, this should be equal to n minus 3. If we put equal to here, that then we have to put n minus 3. If we don't put equal to here, we have to put n minus 2. Okay, then first take the condition, like if I is greater than 0, and then num equal to nums of I plus 1, so I minus 1, then simply continue. Okay, then put another, okay, let's see that later. Int left equal to 0, sorry, I plus 1, and right equal to n minus 1. So while left is less than right, have to first calculate the sum, and sum equal to nums of I plus nums of left, or rather left plus of right, we get the sum. If the sum is equal to 0, then simply go and push this into an array. Okay, so pick a vector of answer. We just take answer dot push back. I think this should work. We take another vector here, that is this 3. Just put that here. I think this should work, because at the end this is a vector. We add this to another vector, left plus plus, right minus minus. Here we have to take another condition, which is while till we get left is less than right, and we put the condition array of left is array of left plus 1. So norms of left is equal to norms of left plus 1. For this case, the two values are same. If we get here, we have to put a left plus plus. Always do this thing. Again paste it, and it should be right, and right this one, it should be right minus minus. Okay, else if sum is greater than 0, then it's simple. It is greater than 0, we have to lower it, right? So right minus minus, else left plus plus. Simple. While loop here, just turn the answer here. I think this should work. Okay, null value. Sorry for this. The answer should be here, not there. Okay, it work. Does it run? Okay. Why we get a wrong answer? Two should be a valid answer, but it not put this here. Okay, let's check where we make a mistake. Hmm. Condition is here is okay. Okay, okay. We put it here. Think we made this mistake here. We have to put both of the things at the end. This, yes. This is the thing that I like. Still, the answers are same. We have to, yes, before left plus plus and right minus minus. This is also a mistake in pseudocode. This line should be at the end. Why? because first we check if we get any common element or not. If we get any common element, just increase it, increase it, increase it till the last common element. If we get till the last common element, we just suppose it here like j is increasing, like k is here, j is here, j is increasing -1. Then again, if -1 here, then again just goes here. Okay, this is -1 for, and it will stop because j and j plus 1 are not equal here. Suppose left is j, so left plus 1 here. J and j plus 1 is not equal, but this should give the same sum as this, so we have to increase it here. We increase it here. Okay, for this reason we are doing it again at the end. Okay, and I think we should put another condition here, that is if nums of I is greater than, make it, because we are, let's suppose, okay, let's suppose an array, let's suppose this array like -1, this should be, let's suppose this array is given to us. If I is here, this, okay, let's suppose this is the I. Now here this I is already greater than 0 and we already sorted the array. So if we sorted the array, there is always a chance that the next element, it would be equal or greater than the previous index. So just take j. The array is sorted, so j is always be greater than or equal to I. So I is already greater than 0, then j should be greater than I, and also the k also should be greater than I. So the condition is like k is greater than equal to j is greater than equal to I. So for this condition we can put it here. If we get the element greater than 0, there is no chance that we can get another element that is that sum equal to 0. And if we get it here, if the I moves here, the answer is always the same. So we break, early breaking we are doing it here. This is an early breaking so that it should work. Yes, it works. This condition, this just come in my head, it should be worked. Okay, so we solve another solution, and the time complexity, actually we use a for loop in -3. We use a left pointer and a right pointer. Left should be here, right should be here. Max case in -1, in -1. So the I will run like in -3, and then the while loop runs in minus, not technically in -1. If all are equal, then the k just moves, it will happen equal. So the greatest term here is n square. We get another term also. So we take the greatest term as time complexity. So time complexity here will be big O of n square and big O of square. And we don't take any extra space, just a space to return the answer. So this should be size of the answer actually, but we can also say O of 1 because we have to return the answer. So use it. We don't use any extra space than this array. We just use this. We don't use any extra space. And sorting is n log n, so it less than n by 2. N square. So the time complexity would be n square and the space complexity would be big O of 1. So okay, we done it. We complete our threesome problem here. This is a great resource. Go use it, check it out. Use this link, this following link, to get a 7-day free trial. Get the 7-day free trial. Use this link. This will help you to get a 7-day free trial. Use it. Go to the platform. Use it. Feel it. Thank you very much for the video. This is a very great platform. Go use it using the following link. Thank you.